Hey, good morning, everybody. This is Mr. Ainsworth, and we are going to get into Unit 8, Lesson 1 here and talk about polar form and how to graph points, all right, in polar form, uh, in addition to your Cartesian form, the way you were taught how to graph points from the beginning. All right, so here's how it's done. We all know how to graph a point given an ordered pair x comma y. So let's draw a little picture here to represent that. Okay, so on the polar grid that you're looking at here in the quick notes, you'll notice that you have a bunch of concentric circles here, and they're just circles with the same center, which we call the pole in polar grid. Okay, that's called the pole, oftentimes called the origin, right? Okay, so the pole is the same thing as the origin, and the x-axis now becomes the polar axis, right? Where we refer to our rotations right there. So I'm going to draw this in as red. So we're going to highlight the polar axis right through here, starting at 0 degrees or 0 radians. Okay, let's refer to this as the polar axis. And this is where we start our rotation given some polar angle. Okay, so let's plot a point here in general, and let's just talk in general here, and we'll get into specifics here in a minute. But let's say we have a point up here. It doesn't matter where. Just go on the 1, 2, 3, 4, 5th circle there at pi third radians right there, and call that P, we'll call it just as a reference point right here. Okay, and that P, has rectangular Cartesian coordinates x comma y. Okay, we already know how to graph points in that form. That's called rectangular form or Cartesian form. Rectangular form. The reason why they call it that is because typically our axes are perpendicular, right? And they form little rectangles, all at right angles to one another. That has a special name called Cartesian form from the guy who invented this stuff, the Frenchman named René Descartes back in, I think, the 1700s. So Cartesian or rectangular form is in the form of x comma y. And what we want to do today is learn how to graph the same point, but in what's called polar form. All right, in polar form, all right, it looks like r comma theta, which I will explain here in a few minutes. All right, so let's go to the graph here and let's do a little plotting here. So to get to point P, we're going to have to draw the little right triangle here. We're going to have to go to, x units to the right, go y units up, and you're at point x comma y. And the distance from the point P to the pole, or the origin right here, so let's draw that. There we go. Okay, we're going to call that r. And the reason why we call that is because it's actually the radius of the circle. Because all of these circles that you're looking at here, these are called concentric circles, have some radius r, which represents the distance from the point to the pole. All right, and that's called the modulus in the complex number system, but we're just going to call that r, okay? R for radius. So r for radius here, because it kind of looks like one, kind of makes sense, right? All right, and theta is the angle of rotation from the polar axis rotated counterclockwise to the radius. So let's signify that. Let's draw that in. Okay, so we're going to rotate here, theta, either theta radians. So again, starting from the polar axis, rotated, all right, in a counterclockwise manner, CCW. All right, so if the angle is positive, you rotate counterclockwise. If it's negative, believe it or not, you go the other direction. All right, negative refers to a clockwise rotation. And this I've discussed with you guys before, so you should understand that. All right, so our goal right now is to represent or to be able to convert back and forth from Cartesian to polar and back and forth. Now, given the two coordinates x comma y in rectangular form, how do you find the distance to the pole called r, and how do you find that polar angle? Well, it's actually not too bad. Okay, so what we're going to do is we're going to get some definitions going. Okay, so we know from SOHCAHTOA. Okay, so basic trig facts here. SOHCAHTOA here, that the tangent of theta here, okay, this is how you find your polar angle. So the tangent of theta is equal to y divided by x, opposite of theta divided by the adjacent side. So that's nothing new. And to solve for theta, you have to take the inverse tangent, right, of the ratio y divided by x. All right, we've done that before too. This will give you an angle, all right, between negative pi halves and pi halves because it's restricted right here. So remember, theta, the inverse tangent theta has to be between negative pi halves, okay, and pi halves. Oops, I should have made that less than, strictly less than. Sorry, let me fix that. Okay, this tangent function has asymptotes, so it has to be strictly less than from negative pi halves to pi halves. And as you guys know, if you do a little plot here, negative pi halves to 0, that's quadrant 4, and then 0 to pi halves, that's obviously quadrant 1. So when you take the inverse tangent here, you get an angle in quadrant 1 or 4, and then you'll have to adjust for the quadrant, okay? So adjust, and you'll see me do this here together here. Adjust for the correct quadrant that you're working in, all right? Because if the ratio y to x is positive, it'll give you a quadrant 1 answer. But let's say the points in quadrant 3, you're gonna have to add pi. So we're gonna have to adjust for the correct quadrant, to get the correct angle. You'll see me do that. Okay, so that's how you find the polar angle. So theta is the polar angle here. Polar angle. Now the radius right there, r, is found by using the Pythagorean theorem, because this little triangle here that you guys are looking at is a right triangle, right? And the Pythagorean theorem applies to this. So when you do this right here, you apply the Pythagorean theorem. Just go back to basics, go back to geometry back when you're little, right here. And you guys know that x squared plus y squared is equal to r squared. And if you're solving for r, well, you square root both sides, and r is equal to the square root of x squared plus y squared using your Pythagorean theorem. All right, so if you're given coordinates x comma y, it's easy to find the radius, okay, by using the Pythagorean theorem. All right, so just square root the x squared plus y squared and you get your radius. And then for theta, you just use the tangent function, and you take the inverse tangent of y divided by x, get an angle in either quadrant 1 or 4, and adjust for the quadrant, and you're good to go. And that's your first basic skill. And of course, given polar form, you can go back to rectangular form as well. Now, if you're going to do that, going from polar to rectangular, let me make a little note here. Going the other direction here, you're going to have to use your other functions. So let's talk about that. So looking at your triangle here, and this is what you do if you want to convert polar back to rectangular. Okay, we know from the diagram up here, and again, this is basic trick here, cosine is the adjacent divided by hypotenuse ratio. So we know that cosine theta is equal to x divided by r. And if you multiply both sides by r, you get x is equal to r times cosine theta. And we also know that sine theta is the same thing as y to r. And if you multiply both sides by the radius, you get the y coordinate is equal to r times sine of theta. So if you're going to rectangular or polar form to rectangular form, which is just, you got to find your coordinates x and y here, you just use your basic definitions of sine and cosine to get those x and y coordinates. And then, of course, you express your answer in rectangular form, which is obviously x comma y. And it's that simple, right? But if you're going to go from rectangular to polar, well, you got to use the inverse tangent, and you got to use your Pythagorean theorem. All right, and that's all you really need to know. And basically, all of this you already do know, so it's just getting used to it, guys. Okay, and getting used to it. So let's get used to it. Let's go for it. All right, so let's develop some understanding here and do some problem solving. Okay, plot the points on the polar grid. Then give two other polar coordinates of the same point. And you're going to find out that, in polar form, every point has an infinite number of representations. okay? Because angles can be coterminal, as you guys know. So let's go ahead and play with the idea here. So let's call this point. Let's call this point A, and the second one let's call it B. And remember, this is polar form, so this is r comma theta right here. So the radius is 3. Theta is pi thirds rotation, and this is rotated counterclockwise because it's positive. Okay, so here we go. Um, so what we want to do is go out to the third circle here. So you count 1, 2, 3, and then you rotate pi thirds radians. So rotate. Okay, there we go. And we're here, and that's at point A because we're on the third concentric circle, and we're at pi thirds radians. So 3 comma pi thirds. Okay, so you go out to the third circle, to the third radius, radius 3, and then rotate pi third radians in a counterclockwise manner. And it's that simple. Now it says give two other coordinates, right? Two other polar coordinates for the same point. Okay, well, there's many different ways you can do this. Well, one thing you can do is just add 2 pi to your angle. Okay, so because if you add 2 pi, you get coterminal angles. So since, let's see, since pi thirds plus, you can go plus or minus, by the way. Okay, since this is coterminal. Okay, so coterminal. So we want to add these two together. Now 2 pi is 6 thirds, and 6 thirds plus 1 third is 7 thirds. So this is 7 thirds pi. So another point that is at the same location here is 3 comma 7 pi thirds. Okay, because 7 thirds is coterminal. That's one way you can do it. So you can add 2 pi. The other way is subtract 2 pi. So you can also do that as well. So let's take pi thirds and subtract 2 pi. Let's try this one here. So if you subtract 2 pi, this is the same thing as pi thirds minus, all right, 6 pi thirds. Again, this is the same thing, right? And then 1 third minus 6 thirds gives you 5 thirds, or negative 5 thirds, excuse me, because we're subtracting 1 minus 6 is negative 5. So you get negative 5 thirds pi as our coterminal angle. And this is a clockwise rotation right here. So my next representation would be 3 comma negative 5 thirds pi. And believe it or not, these are in the same location. Okay, they're the same. So 3 comma negative 5 thirds pi. How do you get there? Where you go the other direction. And remember, 5 thirds is 1 and 2 thirds. So this is negative 1 and 2 thirds pi rotation. But it is a clockwise rotation because it's negative. Again, these are all basics that we've talked about before. So you got to go 1 and 2 thirds pi around. So this way it would be rotating pi would be a half revolution. Okay, and then of course, so this is pi radians here, and then you have to go another 2 thirds around. So here would be another 2 thirds. I'm trying to represent this for you guys, so you can see it. So pi plus 1 pi plus 2 thirds pi is 1 and 2 thirds pi. But again, I'm going in a clockwise direction here. This way is clockwise for positive angles. Excuse me, negative angles. Come on, Aynesworth. Okay, so you go clockwise for negative angles. And then if the angle is positive, okay, you go counterclockwise. You go this way for positive angles. Counterclockwise, CCW. Okay, and that's why it's coterminal. And if you end up at the same point, well, guess what? The angle or the point can be represented multiple different ways. In fact, there's an infinite number of representations for every point in polar form. Okay, so there's a little note. Let's make a little note here. There, let's say there is an infinite, okay, number of representations for every point in polar form. Okay, in polar form, not rectangular form. There's only one way to represent that. Okay, but in polar form, because angles can be coterminal, meaning they terminate or end in the same place or position, All right, every point in polar form has an infinite ways to write it. Okay, now there is another way to do it, and you can have a negative radius. And let's go back up here to quick notes right here. If you want to graph negative r comma theta, if r is negative, it's a reflection over the across the pole, or basically 180-degree rotation in the, or you can think of it as in the opposite direction. So if you're going to be graphing r comma theta, let's say p can be represented as r comma theta. So look at the top of the screen. If you go in the opposite direction, let's say right here, this point would be negative r comma theta, where a negative radius would just be a reflection across the pole or a 180-degree rotation in the opposite direction. Okay, so negative radius, just make a little note. Okay, means that you have a reflection across the pole. Another way to think about that is it's a 180-degree rotation, okay, in the opposite direction. That is another way to think about it. So if we wanted to do this, what we could do is let's go back to number one again here. We could rotate, go in the opposite direction, but a different angle. So let's say negative 3 comma, let's say 4/3 pi. Okay, so how would we do that? So we'd go, let's go, instead of going right 3 on the concentric circles, we can go left 3. 1, 2, 3, 1, 2, 3, and then rotate 1 1/3 pi, and you'll end up in the same position. So in this case here, if you go left 3 units, okay, and then rotate around, and again, this 4/3 pi is a positive angle here, so you're going to be rotating in a counterclockwise direction, 4/3 pi, you'll end up at this same position. Okay, so that negative r, negative radius, is just a reflection across the pole, and there's different ways to interpret this or graph this. And as with everything here, it's a lot easier to explain in class when I'm actually working with you guys, which I will do. All right, now point B is negative 5 comma 7/4. So where would that be? So what we can do is we can go, let's see, so one way to do it is to, well, 7/4 is 1 3/4 pi. So let's see, let's do this. Let's go radiate out to the left 5 units and then rotate 1 3/4 pi. And then let's see what happens. Okay, let's see where we end up. All right, so let's see here in green. So go out to the 5th circle to the left. So one. So let's see, 1, 2, 3, 4, 5. That's on the dark one right there. So go out to here, right, and then rotate 1 3/4. So go all the way around. That's 1 pi. Plus here's 1/4, 2/4, 3/4, and you end up here at point B, right there, and that's going to be at negative 5 comma 7/4 pi. That's one way to do that. Okay, you can rotate out. Again, go out to the 5th circle to the left instead of to the right because it's negative 5 instead of positive 5, and then rotate around. That's one way to do it. Another way to get to point B is simply just to rotate in a counterclockwise direction. All right, so we could, this would be equivalent to 5 comma 3/4 pi, and you end up in the same position right here. Okay, or another way, you could go 5 out 5 to the right, and then you could go clockwise, which is a negative angle, and you could go this way. Let me see if I can represent this. All the way around, and then plus another 4th this way, and that would be a negative 5/4 pi. So I could say 5 comma negative 5/4 pi, And again, this is a clockwise direction here because it's negative. Or you can go counterclockwise if you want to express it as a positive angle. You just got to get used to it. All right, and that's plotting points in polar form. Number two, do the points 3 comma pi 6 and negative 3 comma 7 6 pi have the same location? Well, why don't you plot them here? So 3 comma pi 6, let's see here. Let's get a different color. Okay, so 3 comma pi 6. So if you go out to the third circle, 1, 2, 3, and then rotate 5, 6. Let me see. Oh, it's just pi 6. Okay, so pi 6, so 1, 2, 3, 4, 5. And then, no, 3, sorry, 3 comma pi 6. So 1, 2, 3, third circle, and then pi 6. We'll call this point C. And then here, if you go do the same, but you go left 3 units and then rotate 1 and a 6 pi. So this is 1 and 1 6 pi. So we end up in the same position. So you go out 3 to the left now. So 1, so 1, 2, so 1, 2, 3. And then you rotate 1 and 6 pi. So you go all the way around, okay, halfway around, and then 1 6 more. Oh, yes, they are. Okay, so they are in the same position. So yes. All right, what can you conclude about the two polar angles? Well, guess what? They're pi radians apart. They're half a circle apart. So pi radians apart. Or you can say half a circle apart. And that's always going to happen. All right, number 3. Okay, let's do a little converting. So let's have a little fun with this. Convert the point 4 comma 2/3 pi to polar to rectangular coordinates. And we're talking x comma y. All right, so here we go. So x is equal to r times cosine theta. So again, this is r comma theta, right? So you just substitute your values in. So take 4 times cosine to 2/3 pi and evaluate. This is quadrant 2. Negative cosine is negative there. So this is going to be negative 4 times cosine of pi thirds, or cosine of 60 degrees, which is 1/2. And so you get negative 2 here. And then the y coordinate is r times the sine of theta. So you take 4 times the sine of 2/3 pi. And it's in quadrant 2, sine's positive. So it's going to be 4 times the sine of pi thirds, or sine of 60 degrees, which is rad 3 over 2. And so here you're going to get 2 rad 3. So my point in polar rectangular form is negative 2 comma 2 rad 3. Okay, so 2 rad 3. That's called rectangular form or Cartesian form. Okay, now the other way around, right? So we're going to take points in rectangular form, convert to polar. Okie dokie. So here, all we have to do is find the radius, so, and the polar angle. So here we take the square root of 2 squared plus, let's see, plus 2 rad 3 quantity squared. So r is equal to 4 for the square root of 4 plus, let me see, 4 times 3 is 12. And that's the square root of 16, so r is 4. So the radius is 4. And then you use your tangent function. So tan theta equals 2 rad 3 divided by 2, which is just rad 3. And then you ask yourself, when have you seen that ratio? Okay, so I'm going to bring up the 30, 60, 90 here, which has sides 2, 1, rad 3. And we know that the tangent of 60 degrees has the ratio of root 3 to 1. And 60 degrees is just pi thirds right through here. So, and this is a quadrant 1 number. Okay, 2 comma 2 rad 3 is in quadrant 1, Q1. And so I know theta is going to be my pi thirds angle. And so that tells me I get r comma theta. So r comma theta would be the radius of 4, and then the polar angle pi thirds. And there we go. Now if you graph 2 comma 2 rad 3, if you just take a look at it here, so 2 comma 2 rad 3, you would have to graph it at 2 comma, let me see, 2 times 1.7, that's about 3.4, so 2 comma 3.4. So you go right 2 up 3.4, which would be right about here. And if you look at it, so this is pi 6, this is pi fourths, and this is pi thirds on the polar grid. This makes sense, okay? Take a look at it. It's on the line there, right at the angle at pi thirds, and that's the polar angle. Check it out. So it actually makes sense when you graph it. And then last one here, number 5. Which point is further from the origin? The point with these rectangular coordinates, or the point with the polar form? Well, polar form, we know that r is 6 here, so it's 6 units away from the origin. Okay, so 6 units away from origin. Okay, or you can say pole. So the only thing you have to do is figure out the r value here, your distance from the pole. So you got to take the square root of -5 squared plus 3 squared, and you got to simplify it. And it's the square root of 25 plus 9, which gives you the square root of 34. And the square root of 34 is less than, all right, the square root of 36, which is 6. Okay, so this number here is less than 6 units. So it's less than 6 units, okay, away from the origin. Okay, so which one's closer? Well, guess what? 5, -5 comma 3. So now let me see. What to say? Which one's further? Oh, further away, right? All right, so guess which one's further? Well, 6 comma 5 halves pi. So this guy, here's our final answer. 6 comma 5 6 pi is further away, because that's what it's asking. Further away from the origin or the pole. There we go. That is the conclusion. All right. There we go. So you just have to compare. You have to know what 6 means in polar form, and then you have to know how to find r, the radius, if you're given rectangular form, and then you just compare. I thought that was a cool problem. Okay. So of course, now you apply it here. So go into the application, give this a shot. I'll let you handle it, and you can check it with my instructor's notes later. All right, but this is the application of what you just learned. Okay, so give it a shot, then check your homework out. Hopefully this helped you out. It's Ainsworth here, and hopefully I'll see you guys in class. Take care. Bye-bye.